Okay, cloud. Basically, the question that we're addressing is first, what is it? What types do we have? What features does it have? And then we're going to go ahead and look into a couple additional specific cloud approaches, OpenStack and AWS being big players in the space. They're not the only players in the space, but they're certainly ones worth looking at. Question 1, what is the cloud? So the historical theory of the internet is that it floats out in the world somewhere, and what we can do is we can send messages out into the internet, which lives between computers effectively. And while the reality is all of the work gets done on specific computers, the impression, if I am sending messages out into the web, is that, oh, well, something out there that's kind of amorphous does the work and sends me back a response. Sounds very reasonable. And then, over time, we slowly started taking that a little bit more seriously. We would say, hey, I would like to be able to host, I would like to rent from somewhere a place to host my website. And so I'd go rent a place to host my website, and they'd say, okay, what do you want on your website? And I'd say, okay, well, this one I need MySQL, and I need Tomcat 7, and I need an assorted set of other technologies. And they'd say, okay, and they'd put together my image, and they'd host it for me. Sooner rather than later, folks doing that ended up discovering, you know, that's taking up an awful lot of computer space for relatively low value for, I mean, we're getting paid for it, but we're basically using an entire computer. It would probably be better if we didn't have to use an entire computer. Heck, it would probably be better if we could separate out pieces of our computing system. And so folks started effectively trying to chop up what we could do with the computer. And so maybe instead of having one computer hosting one site in an isolated fashion, we want to be able to have a single system host 2 sites, or 3 or 4 or 20. But the problem is, how do we do that in an isolated fashion? And so folks started working on building systems that could host, building software that would allow us to treat one PC as if it were several PCs with all of the protections in between that we would like. And we started getting into the topic of virtualization. And so now we have virtualization, and the notion is one computer can host several virtual fictional computers, and it can distribute its resources, be those storage type resources or computing type resources, to the virtual systems that are being hosted. That's a nice step. that moves us forward. And that means that when I go out and I talk to some hosting service like GoDaddy or whatever, I can go out and say, hey, I would like you to host my site. And they say, yes, we will deliver you a hosted site with good security and all your own stuff, and other folks can't get into it. And that basically means we're going to build a image and we're going to host your image for you. And all you have to do is interact with your image as if it's a whole computer. And that's great. So that notion, the notion that I can start getting computing services, and we'll start off with just straight up computing power and storage. The notion that I can get computing power and storage without really renting a specific machine or buying a specific machine, that's the start of cloud computing. Very worthwhile thing to be doing. And then people started saying, oh, okay, well, what can we do beyond that? And that's the discussion of cloud computing. So we've got an analogy here, cloud computing similar to electrical power. When I buy extra electricity, when I plug in an extra device, another computer into my system, I start drawing additional electricity. Yes, I have to pay for my additional electricity, but the electrical capacity is out there, and all I have to do is plug in and I get access to the additional capacity. What this allows me to do is have folks who specialize in power generation instead of having everybody working at home with their own generator or solar cells or whatever. So not a horrible analogy there. What cloud computing has turned into is places like GoDaddy or VMware or Amazon ended up with lots and lots of computing power being used to do one of their jobs. And eventually they had lots and lots of computing power being used to do some of their job. And they said, gosh, we have this computing power and we're running into a situation where sometimes we need a lot of it and sometimes we need a little of it. But what we really find is that we, along with everybody else, needs the ability to scale our computing power. Sometimes we need 90% of our systems doing our stuff. Sometimes we only need 30% of our systems doing stuff for us. And that kind of variable load is fairly standard among systems. So if we could potentially use our expertise at managing large bundles of systems, the way we used to manage data centers, then a lot of folks could benefit. We could deliver computing power and storage to folks at cheaper rates than what they could get normally. They could get computing power that scales without buying a server full-time. If what we could eventually give folks the ability to do is we could give folks the ability to buy or rent a server in a part-time fashion. And buying or renting partial servers in a partial servers for partial part of the time can be a lot cheaper than getting a whole server full-time, right? Costs maybe $1,000 to get another system built up and plugged in with processor and motherboard and storage plugged into a rack, right? If I can rent a system that I need for 4 hours every weekday, and I can rent it at a reasonable rate of a couple dollars an hour, that means that I've got like 12 plus weeks of running at relatively low rates in order to, before I end up with the expense. Also, that's just the purchase expense. That's not the maintenance and related expense. And so what we find is if you don't usually need, you only sometimes need the computing power, it ends up cheaper a lot of the time to just rent partial space. And the first round of cloud computing is renting partial space. That doesn't necessarily constitute the whole of cloud computing, but it gets us there. A lot of that, as I said already, comes down to virtualization. How do I take and make fictional systems so that the hardware is there, but the operating system we deal with is effectively not attached to the hardware? That becomes an interesting question. Once you have that, then life gets more interesting. Of course, this kind of renting of computing power, that's really the System 390 or IBM Z series model, right? IBM doesn't really sell you servers. What they do is they rent you servers, and so you get to see how much usage of their big machines you have, and they charge you based on usage rather than saying, okay, buy our server and then it's yours and you use it however much you want. So this has been around for a while. What does cloud computing buy you? Fundamentally, the probably single biggest thing it buys you is scalability, and it's scalability on demand without massive early upfront costs. One of the most interesting things I ran into in the early days of the web was folks started building websites. And one of the things about building websites is a lot of the websites that got built, the amount of traffic in the early days of the web was crazy variable, right? There were some number of sites that had large traffic most of the time, but most sites didn't have much traffic most of the time. And so occasionally what you'd get is one of the high traffic, one of the sites that is normally a low traffic site would end up doing something that resulted in it being a high traffic site. And I very distinctly remember a situation in which one of the websites that I was interacting with, it was a home mortgage website, ended up advertising on Amazon. I'm sorry, it ended up advertising on AOL. That was the word I was looking for, right? And when it advertised on AOL, what happened was it went from having 40 simultaneous users, which was a reasonable number, to having 40,000 simultaneous users. And rather unsurprisingly, when that happened, the system went down. Since that happened, and this was in 2001, since that happened, how much computing power you need. And perhaps, and in the case of the example I told you, the mortgage company that went from 4 to 40,000 simultaneous users based on an ad in on AOL. Okay, fine. That that gets us somewhere, and you can predict some of it. But that's only predicting some of it. Not all of it. Sometimes you get spikes in usage that you didn't actually write ads for. And those spikes in usage are need to be handled. To a significant extent, because I think of that as central to the computing problem in general, effectively, cloud is built to solve that problem. If I have an infrastructure that is built to support 40 simultaneous users, and for 5 minutes of my day I get 40,000 simultaneous users, how do I scale to that level? Well, the cloud computing solution is you set up additional servers or you set up on-demand servers, and when your traffic gets high enough, you simply turn them on and make sure that you have a web load balancer in front of this that can forward the requests on to the appropriate locations. And now all of a sudden, instead of having your 2 or 3 systems that work together to handle that kind of load, your 2 or 3 systems can be 300 based on automatic provisioning of resources, and then half an hour later, when the load's gone, all of the additional resources can go away. From the point of view of business, it would be incredibly wasteful to buy the 300 systems necessary to handle peak load. From the point of view of business, it's also a really bad idea to have an infrastructure built to handle 40 simultaneous users, which could support 100 or 400, but which crashes when you get to 1,000, if we will get occasional spikes up to 40,000. That's just not a good setup. And so without cloud computing, without the ability to temporarily rent space and processing power for our systems to run, we basically have a problem. Not a very good solution. So that's number one. The scalability, the just-in-time, on-demand infrastructure setup, that's incredibly valuable, and in the modern world, I don't know how much you can live without that. Right now, one of the things that is going on a lot is testing. If you end up building a set of automated web tests, then honestly, I need to set up a platform to do my web testing from. And so a lot of the time what I end up doing is I end up turning on a cloud computing instance, saying, okay, I need my cloud system set up. Turn on the cloud system, run it for 2, 3, 5 minutes to do all of my testing, and then turn it off. And so what I'm doing is using a system for 5 minutes out of every hour, 5 minutes out of every other hour, something like that, in order to do testing. And so I use the system for 20 to 30 minutes a day. Is it worth buying a system to do that? No, it's not. But renting a system for 30 minutes a day to do a lot of my testing work means that as a developer, or as the person who pays developers, I don't have to buy another system to support that work. Of course, this gives you the ability to rent rather than buy. It gives you variable costs over fixed costs. You don't have big upfront costs. I have pay-as-I-go cost models. If my pay-as-I-go cost model turns out that I'm using it enough, I can buy a system and save money. If I'm only using it enough to justify renting it, though, it's a much better cost approach for us. Also, the business of setting up a new system without a serious DevOps initiative, most folks at most organizations, if you say, I need a new server, it's not going to be ready in the next 15 minutes. I want a new server normally results in a day to a month of delay. If I can configure a system setup and then say, can I have a new server turned on, and it can be turned on inside the hour, that's a completely different level of capability. And if you're only using a platform for, as I said, 5 minutes every couple hours, then this gives you all sorts of efficiencies. Okay, so that was a lot about cloud and about history of cloud. Let's continue forward. when we talk about cloud, what types of work might we do? Mostly, cloud comes in 3 categories with a 4th category starting to show up. First layer is infrastructure as a service. Essentially, the beginnings of cloud came up when somebody said, look, I need to be able to sometimes have 5 extra systems and sometimes need no extra systems. How do I make that work? And we got virtualization going on. We have hosting companies like Rackspace. You have big players in the Silicon Valley and Seattle software markets who just had insane amounts of computing power that they weren't using all of the time, and they needed to figure out how to shift computing power between divisions inside of their system. And so they said, hey, I would like to basically provision machines, give them variable amounts of computing power and storage, so that maybe I have one 2-core machine that runs at a couple gigahertz, and what I'd like to be able to do is break that 2-core 2 gigahertz system up into 5 different machines, with each one of them having a 1/5 of that computing power and storage capacity. So great, we can do that. We can separate out and effectively give you a computer with an operating system, storage, and network capacity, and that's all, right? That's called infrastructure as a service, and it's the foundations of computing, because everybody sets up their stuff differently. After a while, though, it turns out not everybody sets up their stuff differently. There's a relatively small set of setups that folks like to do. If you are doing software in the modern world, right now, and this isn't true, but it gets close to true. If I say, okay, what languages are people developing in, right? I'm going to build a full stack web application. What might you be developing it in? And an awful lot of our work these days is either full stack web applications or a service that lives behind some sort of full stack web application. What might you develop a web application in? Well, as far as I can tell, there's the number of choices that we have to do that has been dropping over time. Today, I believe that somebody might do a .NET system. I believe that somebody might do a Java Enterprise Edition system. I believe that somebody might do a mean or a mean React stack. I believe in Python. I believe in Ruby on Rails. And then I start asking the question of whether there's any more things to believe in, right? If I'm building modern web apps, it's .NET, it's Java, and I'll even go further than that. It's Java with Spring Boot. So I've got .NET, I've got Java with Spring Boot, I've got JavaScript, and by that I mean React. I have Ruby on Rails, or I have a Python stack. And Yes, I believe that Go has started to increase usage. I still don't think of it, and maybe I'm wrong, I think of it as a smaller player. But if we take this seriously, there's only maybe half a dozen standard stacks in the industry. Maybe instead of giving somebody a operating system that's more or less clear and they get to do anything they want with it, or even a virtual system that they can install their operating system on, maybe I should give them a pre-configured system that already has everything. Hey, here's a system that already exists that has Java 8 installed and Python. Sorry, it has Java 8 installed. It has Tomcat. It has Maven and Gradle available, right? And so the system's already set up. If we have standardized development environments like that, that might be better than infrastructure as a service for a lot of cases. As far as I can tell, that approach is doing very well right now. The biggest new player in this space appears to be Pivotal's Cloud Foundry systems, which are, again, used a lot for testing and dynamic environments during development. But the whole platform as a service thing is working very nicely. Microsoft also has their Azure stuff where you can get a full .NET platform very, very conveniently just by blinking at them. Google does that, Amazon does it, pretty much everyone now includes that in the choices besides just the low-level system resources. And then the third thing that people started doing with, once you had infrastructure as a service and platform as a service available, is folks started saying, you're hosting a system on your resources, or rather, some people are hosting systems on their resources. And so if you are IBM or Price Waterhouse or GE or something, and you have a sales organization, then you host sales software on your system, and you can go out and do sales work, and you have a bunch of software support to keep track of your sales work. And if you're a smaller organization, then very simply, you don't have that level of support. You are frequently looking for something that can do that, but you simply can't afford the startup costs to make it happen. What software as a service does is says, oh, you can't afford the startup costs? That's fine. We can help you support the startup costs by really not asking you to do startup costs at all. What we'd like you to do is simply rent our sales management software. And so we will build the software, we will deploy the software into the cloud, and then you can sign up where you rent room as 5 users, and now you can have all of the capabilities that a big organization like IBM has for sales support software without any of the upfront costs. All you have to do is pay a low monthly fee and everything works. Salesforce is probably the best known example of that, but thinking back to the early 90s, email was a by organization approach to doing electronic communication, and every organization had their own. Honestly, webmail is an earlier instantiation of the same thing, where we're doing software, the software being email. So there's a question. I'll hit that in just a sec. Email is another example. Any form of webmail, Gmail just being the one that is most commonly used now. But then Adobe has moved a bunch of their stuff into the cloud. Apple has their iCloud. Dropbox is a file system in the web. Okay, so the question is, if you're using software as a service, then how do you integrate it with other software in the organization that may not be in the same cloud? For example, we have sales. We have sales on the cloud, marketing, and internal system. So there's a really short answer to that, and I'm going to give you the short answer. Manage it? I'm sorry if I said that wrong. The short answer is software should be linked loosely. Historically, we build large systems and we integrate them together tightly, and that means that when I make a change to one, it can break everything, and that's a central sin in modern software. Too much of software needs to be able to change quickly, and so if you do tight linkages, you lose the ability to change. All modern software is developed with the theory that we have loose linkages. And loose linkages today means we use web services to communicate between component A and component B. Component A can show their data via web services. Component A can send their data with web services to another place. Component A can download their data in a specific format, and you can then send it to system B. But all modern systems, regardless of where they sit, should be separated into loosely coupled pieces that interact through basically web services or standard data formats. If you have an internal marketing system and sales is external via Salesforce, the correct way to handle it is through standardized interfaces. You can get some of the Salesforce or most of the Salesforce data via standardized interfaces via web service links, and your internal stuff should talk to the Salesforce via web services. The good news is, if they were both hosted internally, that's also the way you should do it. You should have your marketing application talk via web services to your internal sales application instead. Okay, short answer is loose coupling web services is most of the answer to talk. They don't have to be in the same place. If you can access them through the internet, we're good. Okay, I've been focused so far on outlining web services. That's where most of my energy has gone. We're going to move forward into making sure we hit a little bit on the technical side. So I hope that answered some of your question. If not, we can cover more at the end. Manage it. How do you do cloud? Well, short answer on how to do cloud is there's really 3 answers. Choice 1 is use the public cloud. Hey, I've got my cloud. I need to expand my resources. I don't have them currently, so let's just rent space from Amazon or Google or Rackspace. Fine. Choice number 2. Oh, well, I know how my usage fluctuations go, and whereas renting server space from Amazon for a couple minutes a day is a standard good approach, if I'm renting 6 or 8 hours of space per day from Amazon, it's honestly cheaper to buy a system. And so we end up saying, oh, okay, well, I'd like to build my own cloud and use my own cloud space. And then, of course, the third option is a little of column A, a little bit of column B, and have some linkages. Choice number 1, I have a data center, or I have the public cloud. I go talk to Amazon. Amazon gives me computing power and storage. It lives outside of my systems. Choice number 2, I have a data center with a whole bunch of computers that I'm not using full time. I turn a lot of them into cloud resources and I host them on site, but set up the same systems. And then I have a hybrid cloud where I have some public stuff, some private stuff, and they talk. Okay. If you are doing cloud computing, there are a relatively small number of cloud computing platforms. OpenStack is what happened, and really, Amazon started winning the cloud computing race. They had their internal Amazon approach where they were building stuff, and then they took the internal Amazon approach and shared the software outside of Amazon so other folks could interact with the same basic system. Amazon stuff is called, not surprisingly, Amazon Web Service. Amazon's shared, hey, other people can do this too, was called Eucalyptus, is called Eucalyptus. Amazon Eucalyptus approach was being used by a lot of folks, but then some form of disagreement between Amazon and the users broke out, and Amazon turned right, the users turned left, and alternate options popped up. The best known and most used of the alternate options, which now appears to be the dominant choice, is OpenStack. OpenStack is infrastructure as a service, and what's happened is Rackspace down in San Antonio is primary driver behind OpenStack, and basically it says you can do a cloud and you can do it exactly the same as basically the Rackspace cloud. It's now run by the OpenStack Foundation, and it lets you do infrastructure as a service on your hardware. So OpenStack has a bunch of components. Mild picture of the OpenStack infrastructure looks like this. There is orchestration, there's a web user interface dashboard, there is identity service, there's virtual machine manager, There's the conductor, there's hypervisor, and there is block storage. Bunch of things that need to be done in a system like this. Let's take a little bit of a look. Short vision of what the pieces are: compute, image, object store, block storage, identity, networking, and the dashboard. They each have a project attached to them. We'll look at the pieces as we move in. So, compute is OpenStack's approach to, hey, I need processing power. It's Cloud Computing Fabric controller. It looks like Amazon's Elastic Compute Cloud. In order to interact with this, we can talk to it via RESTful APIs. Hey, start up a new system, shut down an old system, etc. For computing to work in a cloud environment, you have to have startup and shutdown and restart of the systems. You also have to have the ability to talk to other components, including asynchronously. Rackspace has this capability on their stuff. You can rent it from You can rent infrastructure as a service from Rackspace. And HP does this as well now, but compute is the baseline for doing the Fabric controller stuff. Command line interface basically says, hey, what are my virtual instances? I can get those. I can say, start up a new instance. I can say, pause the instance, but get rid of its computing resources. Bunch of fairly standard capabilities that you can interact with through the command line. If you want to use a window, we have this instead. Remember, if we're doing cloud computing, infrastructure as a service in particular, really what I'm doing is I'm saying, what system image am I going to use? How many copies of this do you need to spin up, right? How much power do we need? And that's most of the situation. In this case, I am in Horizon saying I would like to spin up a tiny system that has half a gig of RAM dedicated to it and no attached storage space. When you deal with cloud computing, you have to deal with two different kinds of storage. Amazon has a storage system, S3, Rackspace and OpenStack's storage system is called Swift, and it's good for storing objects. Objects means we store files, we store blobs, we store disk images. Basically, if all you need is to store a thing, then this is very good at storing a thing. Enormously scalable, right? How big can items be? How many items can we store? Does that very well. Redundancy and failover are both built in. RESTful APIs to get to objects, of course. Backup and archive wouldn't be a good object store without that. If you are going to do anything in the cloud, right, we need to do some form of security. We need to have some form of making sure that if I make a call to a system, that the system A finds out it's me, and B, that other people who aren't me can't get into my stuff. Keystone is the tool that helps to support the identity stuff. Amazon Web Services has all of this as well. Amazon Web Service places this in the cloud. Effectively, Amazon says, we are storing lots of stuff and we figure we could sell our capabilities to other people, and it turned out to be an enormous success. First, the ability to just store data. Second, the ability to provide elastic computing to folks. Eventually, Amazon moved all of their stuff to their dynamic hosting at Amazon Web Services. Here's an enormous set of what we can do. There's scaling, there's computing instances that are on demand or reserved. We have the data buckets set up in S3. We've got RESTful services so you can interact with them programmatically however you want. We've got Elastic MapReduce to do various forms of fancy processing, all sorts of fun stuff. You can get to it via a web UI, a command line interface, software development kit, or you can get to it through RESTful API calls. You can have Direct Connect that lets you hook into Amazon Web Service directly, better bandwidth at lower costs to do that, helping to build your hybrid environments, because most folks in the modern world are moving to some extent in the direction of hybrid environments. Distributed architecture, this lives everywhere. There's no single location. There are a bunch of geographical regions. There's a bunch of availability zones. Amazon has a lot of servers. Things that Amazon will do for you, they've got the Elastic Compute Cloud, which is how you say, hey, I'd like one core of processing for a while. We've got identity management. We have virtual private clouds so that we have IP ranges and subnets and network gateways and stuff. And of course, this helps with security a good deal. We have monitoring of the EC2. We have auto scaling. Hey, if these services systems get used at above this threshold, then spin up a new one. We have load balancing, very, very important to cloud computing. We have block storage that we can attach to EC2. We have simple storage service, which lets us hold data for a reasonable period of time. We have Glacier, which lets us hold longer data for longer, for making it a little harder to get to. We have streaming content. We have caching capabilities. We have queuing, we have notifications, we have a relational database, and we have Elastic MapReduce for doing Hadoop-style MapReduce jobs. Lot of capabilities built into Amazon's web services. Looks like I'm a minute or two past the formal time. We have finished this session. I will be happy to stick around for another 10 minutes, maybe, if there are questions in the area. And in half an hour, we're going to be back talking about Agile architecture. I'm going to mispronounce your name, Moeed. Is that the right way to say it? So I need to understand your question better. What is the action plan for whom? An organization trying to change into this, or you, Moeed, trying to get involved with cloud computing? How do you move into this space? I was not able to tell which one of those you were asking about when you... Okay. So if it's a question of you getting involved, then what you want to be able to do almost certainly is you want to start using the Amazon type tooling, right? There's multiple levels of complexity in cloud computing. One level of complexity is basically going out and using the tooling. Starting off with a use of either Amazon's products, just basically have the ability to scale. The easiest thing to do is to set stuff up so that when you are doing some form of web hosting, some applications end up getting hosted on Amazon Cloud, or they end up hosting with a platform as a service things, which can also be done Amazon or Pivotal Cloud Foundry. And so the easiest thing to do is start using either infrastructure as a service or platform as a service from Amazon, Google, Pivotal, somebody. Once you start using it to see how it works, then a second step is building your own. Effectively what OpenStack is for is, okay, I know how to deal with using cloud stuff, but now I'm trying to improve the efficiencies on cloud stuff and set up my own. And so if I'm recommending, I strongly recommend looking into and getting used to using platform as a service, at least infrastructure as a service maybe, which means Amazon or Pivotal first, and then going to OpenStack after that, once you're comfortable using this stuff. Is that an answer to your question? Okay. In general, you want to learn to use it first, and once you know what it's doing for you, once you have a personal feel for, hey, this is helping me here, but I really wish it did that, then when you feel like you can critique how it's getting used, then you want to be able to set it up yourself. That's my generic learning and improvement plan. So yeah. That's okay. If I've answered your question, are there more questions? A bunch of people still sitting around. Okay. In that case, I am going to stop this session, and I am going to take a short break and get ready for the next session. Have a nice 20 minutes.